everybody, welcome to my class. Today's topic is about representation of data. So first of all, we talk about what is representation of data. So in fact, data representation refers to the form in which data is stored, processed and transmitted. So here in this case, you can see that this is defined as the data that approximate and characterize qualities. Qualities means the qualities can be in the form of gender, it can be in the form of personality, it can be in the form of anything that exhibit a particular type of or different type of qualities. Then those sorts of information come under the qualitative set of data. So interview, I have mentioned here, interview means most of the qualitative data are collected via interview. Interview, these are actually in the textual form of the data, and the data that we obtained from interview method are the qualitative data usually. And also we can see the examples of qualitative data as intelligence, honesty, genders, etc. This is also known as categorical data, which can be arranged categorically based on the attributes and properties of thing or phenomenon. Then what do you mean by the category? You can categorize the people according to their intelligence level based on the IQ test. Another thing is that, for example, you have to make a team of people who are going to represent a community, for example. Then you can categorize that team into male, female, junior staffs, senior staffs. In this way, if you categorize the given fact, then those sort of information will be called the qualitative data. And you can see these two diagrams are here. So this is a bar chart and this is a pie chart. So usually bar chart and the pie chart are used for diagrammatic representation of the qualitative data. Now, on the other hand, quantitative data. We have here now quantitative data. So by its name, you might have been able to guess that at least that what is the quantitative data. Quantitative data means it has some fixed size. It is obtained through a certain method where there cannot be less or more than the thing. We have to be exact. Exact means we have to have some numeric form of the data. Then those sort of data are called the quantitative data. So here you can see, like, these data are any quantifiable information that can be used for mathematical calculations or statistical analysis. Quantitative data are measures of values or counts and are expressed as numbers. Alright, so you can give some example of quantitative data, that is the measure of heights, measure of temperatures, number of students in a class who obtain the mark. So if you make the set of those information, that will come under the quantitative set of data. And you can see here one figure I have drawn here. So what does it look like? You can see there are two things. One is that histogram. So connected bar diagrams are actually the histogram. And I have drawn the straight line passing through the middle point of on top of each bar, and you can see that this is in the form of a curve. So that will be called later on the frequency curve or the frequency polygon or again. So in order to represent the quantitative data, this sort of histogram or polygon or frequency polygon or again are very useful in representing such sort of data. And there are also some other kind of diagram that we can use in representing the quantitative data, and that diagram are like this is histogram already here, and then other will be the esteem and leaf diagram. Not only those, there are so many methods of representing the quantitative data, like Lorentz curve, like other sort of curves. There are a lot of statistical and the mathematical method to represent the quantitative data. Now I will discuss about what sort of thing we do in the quantitative data. So in how many ways or in how many types the quantitative data can be seen, that we'll discuss now. You can now see the quantitative data in the form of discrete data and also grouped or continuous set of data. So first of all, we define discrete data. So the data that take only exact values are called discrete set of data. Discrete, literal meaning of discrete means disconnected. That means we define the data at different point, then those sort of data come under discrete set of data. So here we have one example that exhibits what is called the discrete data. So here in this case, you can see that the number of orchestra were asked to how many instruments each could play. So orchestra were asked to how many instruments each could play, and these are their replies. Like one orchestra said they can play two, another orchestra said they can play five, and these are the values based on their replies. Now, in order to illustrate the above discrete data, count number of times each value occurs and summarize this in a table like this. And then if you have table like this is called the discrete data, or the table or the frequency distribution related to the discrete data will be called discrete frequency distribution. So you can have a look at this table. So you can see that the minimum number is 1 and the maximum number is 5. If you search here, and then 5, we have only one 5 here, and then you have to write the how many times 1 is there, how many times 2 is there, how many times 3 is there. So in this way, if you try to find it, so first of all I start with number 1. So 1, how many times 1? Let me count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 means for first 5, this is 5, 5 and 1, 11. And I did the similar work for 2. Now what we can say that the number of instruments they can play is 1. How many orchestra are there? 11. So if the number of instruments played are 2, then it has been done by how many orchestra? 10 orchestra. And similarly for 3, how many orchestra here? 5. For 4, 3 and for 5 instruments player, there is only one orchestra. And if you count this, the total number is 30 here. Similarly, you can see here like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and down to the down also there is 50. So all together there are how many orchestra? There are 30 orchestra in fact. So you can see that different values are defined at different places. That means there are no connection to each other. It's not like 5 to 10, 10 to 15 or something like this. Okay. So 1 has frequency 11, 2 has frequency 10, 3 has frequency 5, 4 has frequency 3, and 5 has frequency 1. So each of the X has been defined at their own point. Therefore, this sort of frequency distribution is called the discrete frequency distribution, because this is based on the discrete data. We can also represent this data by vertical line graph. So you can see here along the x-axis we have number of instruments used, and along the y-axis the number of orchestra. So number of orchestra we take as frequency, and the number of instruments used by the orchestra we take them as x. So here in this case, we can see that if you just to take like the coordinate of x coordinate and y coordinate on the rectangular axis, then for first item we have coordinates 1, 11. So this part is actually, this point is value of x as 1 and another is 11. and for 2 this is coordinate over here is this is 2, 10, and coordinate at this point is going to be 3, 5. 5 is frequency here, and for 4 it is 3, and for 5 it is 1. So frequency 1 is 5, frequency for 5 is 1. So in this way we have these points. So about the x-axis, if you draw a vertical line perpendicular to that value of x, then you will have different vertical lines on the graph, and this sort of graph is called vertical line graph to illustrate the discrete data. So discrete data can also be represented by vertical line graph. Other features that you can see from this vertical bar graph, you can see that the in your analysis, you can see that the maximum frequency corresponds to the maximum height of the vertical line. So vertical line at x equal to 1 has the maximum height, and that occurs at maximum frequency 11, and the value of maximum frequency that corresponds to x is 1. So therefore from this graph we can also say that mode of this data, mode in short we can write this way, this data is given by the maximum frequency is 11 that occurred at x equal to 1. So that occurred at x equal to 1. Therefore mode of this data is 1 in this case. What do you think about to find the mean? So later in the chapter we'll discuss about the arithmetic mean, and there we can see that the mean can be calculated. We mostly calculate the mean based on the table, but sometimes you can calculate the mean from the graph as well. Okay, another form of quantitative data can be seen in the form of group data as well as in the form of continuous data. So in the group data in general, this can be also called inclusive class intervals. Why it is called inclusive class interval is that, so when you come from 0 to 4, it means x is less or equals to 4 and greater equals to 0. If I am talking of this class, that means it includes both 0 and 4. And similar thing happens to the another class also, which is 5 and 9. So here also, if you talk about how x goes, that means it includes both 9 as well as 5. And this is the reason why this is called the inclusive class interval. And grouping is due to that it is given in some sort of interval, therefore the data have been grouped in this case. Therefore, this is called the grouped data. So you can see here the nature of the group data, and that falls under the quantitative type of data. Okay, now I talk about the continuous data. So this is also called the exclusive class interval. So for example, if I am talking of this class interval, so for example, so here you can see x is less than 9.5 but is bigger or equals to 4.5. Similarly, if you talk about any class, for example, here x is less than 19.5 and is bigger equals to this value 14.5. So in this case you can see that if you are talking of this class, it means it includes, according to this sign, it includes 4.5 but it doesn't include 9.5. Then where that 9.5 is going to be included, that will be counted in another class. Therefore the effect of upper limit from each class interval has been excluded here. Therefore this is also called the exclusive class interval, and here the effect of upper limits are included. Therefore this group data is called inclusive class interval. Now we'll discuss about how we can convert the group data into the continuous set of data. So there is a little adjustment that is called the correction factor. So the correction factor is defined as lower limit of succeeding class minus upper limit of preceding class divided by 2. So for example, if I am talking of this and if I am applying this formula, so lower limit of succeeding class, so lower limit of succeeding, this is the preceding class and this is the succeeding class. For 5 to 9, 0, 4 is the preceding class, and for 0, 4, 5 to 9 is a succeeding class. So therefore, if I apply it, then it says that lower limit of the succeeding class, so lower limit of succeeding class is 5, so I wrote here 5, and then minus upper limit of preceding class. So upper limit of preceding class means the previous class, that means it is 4, so divided by, so 4, this is minus 4, and then divided by 5, and similar thing I have done for rest, and then in each case there is value 0.5 for the correction factor. Now, what is the method? Because of its name correction factor, although this is not continuous because of the disconnection between consecutive class intervals, so we have adjusted to make it continuous. So here you can see that. So this is the correction factor. 0.5 is the correction factor number. So this correction factor number you have to deduct from the lower limit, and then this is negative 0.5. And the same number you have to add to the upper limit, then we have 4 plus 0.5 means 4.5. Similarly, if you deduct 0.5 from 5, then it is going to be 4.5. And if you add this 0.5 to the upper limit, always note that to the upper limit we add this 0.5, to the lower limit we subtract 0.5, and then our situation is like this. Now, what difference you can see that from one class to another class, the value hasn't been continued. But here, if you move from one class interval to another class interval, then you can see that there is 4.5. It is now repeated here. That means it is continued to the next class also. So it starts from 4.5. Now it is 9.5. In the another class, it starts from 9.5 and so on like this. So here in this case, there is connection between one class interval to another class interval. This is the reason why this is called the continuous class interval, and it also comes under the quantitative data. So we have seen about group data and the continuous data. Now, what is the difference between group data and continuous data? In fact, both are the same. Grouping means we are grouping in the form of interval, and the same thing has happened here. Here also there is the grouping. Grouping means we are grouping the different numbers in some interval. So in general, both of these data can be termed as group data, but you can say that all group data are not the continuous, but all the continuous data are also the grouped data. Hope it makes sense. Now we can further discuss about mode for this data. So what you can see in this case, if you want to find the modal class in this case, so you can see it is 14 is the maximum frequency, yes. So your maximum frequency is 14. So therefore you can say here your modal class is corresponding to the maximum frequency, and the modal class is 1, 2, 3, 4, 1, 2, 3, 4. So that is 14 to 19.5. It is 14.5 to 19.5. So this is the feature of the group data as well as the continuous set of data. Later on, we'll see this continuous set of data in the form of histogram and other sort of diagrams that fits here. And for the group data, we'll see about the esteem and leaf diagram. Okay guys, we have few more examples of continuous set of data. You can see that 5 to 10, then it continued from 10, then 10 to 15, then from 15 again continued, so 15 to 20, and then 20, 25, 25 to 30 with some frequency here. So this is an example of a continuous set of data. So what is the special feature of this data? You can see that there are two maximum frequency in this case. So here the maximum frequency are, there are two maximum frequencies, so it is 14 and another is also 14, and then 114 is for the class interval 10 to 15 and another 14 is for the class interval 5 to 20. That means it has two modes, and therefore such kind of distribution is called the bimodal distribution. So this is bimodal distribution. So definitely in this case the continuous frequency distribution. And here you can see that there is no frequency mentioned. That means each class interval has frequency 1. So this sort of data is also called the individual distribution, individual frequency distribution, or individual set of continuous data. And you can see that another feature is that it mentions here below 10. So here 10 to 20, the class size is here the class width. You can see that the class width in general is 20 minus 10 is 10. Here also 30 minus 20 is 10. So in general its class width, that is the class interval, is of 10. But if you say below 10, we don't know. It can be 0 to 10. It can be negative 10 to positive 10. It can be anything below that. That means its end point is not open. And here also you can say that above 90. We can't say exactly because of only this difference 10, that this is 10 to 100. No, it doesn't mean that only 10 to 100. It can be 90 to 100. It can be 90 to 9,000 as well. So its end point is also not closed here by any number. So here there can be any number below 10 and there can be any number after 90. Therefore those sort of things are also called the open end class interval, because its end is open. Above 90 means it will go on and on from 90, and below 10 means it can be any number below 10, not only 0 to 10. So here the ends are open, therefore this is called the open end class interval. And this is not necessary that both the ends should be open. For example, if it is below 10 written, and when it is written that 90 to 100, this is a still open-ended class. And also it was 90 and above, and suppose that it is given like 0 to 10. So here the ends are not open, but here in the last class interval the end is open. So in this case also this should be called the open-ended class interval. We shall now discuss about bar chart, pie chart. Vertical line graph has been already discussed earlier. Then esteem and leaf diagram and histogram we will discuss in another class. So in order to discuss bar chart and pie chart, we have this example. This example says that a golf club has 180 members. There are three categories of membership. The categories are men, women, and juniors. There are three times as many men as women and half as many juniors as women. Illustrate the following information using a bar chart and a pie chart. So here in this case we are given that total members or total number of members. You can see this is given as 180. Now when you look at this question, it says that men, women, and juniors, these are the three categories. So there are three times as many men as women. So men is three times as many women. There are three times. Half as many juniors as women. So junior is going to be half of women. So here M stands for men, W stands for women, and J stands for juniors. Now as total is 180 members, that means total means it is constituted by men plus women plus junior, and that is going to be equals to 180. And then men equals to 3 women, we can have a look at here, plus women, we can write W, and junior, relation between junior and this woman is half of W, and that is going to be equals to 100 as total. And if you move forward, then this is 3 plus 1W, that means 4W, 4 to the 8W, and this is 1W is 9W divided by 2 equals to 180, and it gives you W, that is number of women, is 180 times 2 divided by 9. So when you transpose this to the right, so it is divided here, it gets multiplied, and the things that is 9, it is multiplied here. When you transpose this to the other side, it is going to be divided. So 9 1s and 9 2s, and for 0 this is 20. So 20 2s, it is 40. So number of women are 40. So therefore your information is like men equals to 3 times of women, that means 3 times of 40. If you can see here, W equal to 40, and that is going to be equals to 4 3 are 12. So this is going to be equals to 120, and women itself is 40, and the junior, if you see, so junior is half of women, equals to half times of W, that is 40, and 2 1s are 2 2s are, that is 20. So 40 divided by 2 is 20. So you can see that there are 120 men, 40 women, and 20 juniors in the 3 categories. Now the question number first says that you have to illustrate this information on a bar chart. So note it down. Men is 120, women is 40, and junior is 20. Now let's go to the bar chart. So here you can see, like in the bar chart, you can make appropriate spacing between 2 bars and also the width of 2 bars, so that it should be visible to the observer. So here I have taken 1 2 3 1 2 3 4 units inside here. Here also 1 2 3 4 unit gap between these 2 bars. Height of this bar is 120, that represents the men. Height of this bar is 40 because number of women is 40, and height of this bar for junior is 20 because number of junior we have obtained is 20 over here, and hence our bar chart is completed. Here I have shaded this. You don't need to shade it. If you can leave it just like it is, then it works. Or also, if you like, you can shade these bars with different colors, so that in index they will represent the categories like men, women, and juniors. Now in the another part of the question, it says that to represent the given data, that this information using a pie chart. So in order to have a pie chart, what we have to do, we have to find the information in terms of degrees. So if you find the information in terms of degrees, so here it is going to be categories, and at this point it is degrees. So categories are men, then women, juniors, and we have seen it here that number of men are 120, number of women are 40, and number of juniors, you can see here, this is 20. How to convert that into degrees means, so in order to convert that into degrees, so we can adopt like this. So if total, for the total value, your given value, so total value means here we have 180, and the given value for men is 120, for women is 40, and for juniors is 20. So if this is the total value, then you have some given value. If that value is 1, it's going to be given value by total values. And as we are going to convert into 360 degree, so therefore by using the unitary method, so if that is total, then there is given value. If this is 1, then given value divided by total by unitary method. And if that is 360, means it is given value by total value times 360. So you can apply this sense in order to convert this information in terms of degrees. So here you can see this is 120 is the given value, and the total value is out of 180, and this is times 360. You can cancel these two zeros. These two zeros are cancelled here. So 18 1 is 18, 18 2 is 36. That means it is 120 times 2, and finally it's going to be 240 degrees. And women, similar, if you apply the similar sense over here, then it's going to be 40 divided by 180 times 360, and that is going to be equals to, after calculation, it will be 80 degree. And similarly for the juniors, your degree value will be 20 divided by 180 times 360, and then it is going to be 180 to the 360, and this value is going to be 20 to the 40 degree. So we have now converted the proportion of men, women and juniors out of 100 into 80. So out of 300, so here we are talking about out of 180. Now we can talk over here out of 360 degree. Proportion of men is 240 degree, proportion of women is 80 degree, and proportion of junior is 40 degree. So here we have out of 360 degree, and you know that the whole circle or complete circle is 360 degrees. Now let's plot this value, or by using these degrees values, we can draw a circle, and then inside the circle we should draw different sectors that represents the different category as men, women and junior. So here we have found proportion of men is 240 degrees. So you take an initial line, unless otherwise stated, you can take this length as 5 centimeter. That means you can take the radius 5 centimeter, draw the initial line, and about this initial line you can use compass, or otherwise you can draw 240 degree angle. So it's here like, and then give one sort of color or sign like this, and then your another line is here. Now take this line as the reference to draw 80 degree. So about this line you draw the 80 degree, or you measure 80 degree about this line, then your another degree of degree measure will be here represented by this sector. So as this is 240 degree, this is 80 degree, you don't need to draw anything, it is already now 40 degree. So here 240 is for men, 80 degree is for women, and 40 degree is for junior. Here you can see that there is different sign. So you don't need to write different color in examinations. It's not possible for you. Therefore, you can use the same color, but you set this by different sign. So it is minus minus negative sign, and then this is positive sign plus plus, and this is dot dot dot, or you can write any other sign that makes different to each other. And this is most important here is that this sign is used for men. So we have to write this sign is used for men. Another sign is for plus sign is for women, and the dot 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 sign is for juniors. This is called index. So this is most important to, in fact this is compulsory to write the index, especially when you are representing the data by pie chart. So this is called pie chart. Okay guys, we shall now discuss about esteem and leaf diagrams. So this is a way of grouping data into intervals where it still retains the original data in form of diagram is called esteem and leaf diagram, or simply esteem plot. This can be explained further by an example like this. So this example states that the daily hours of sunshine in a particular city during August were as shown below. So this is the daily these are the data for daily hours of sunshine in a particular city during the month of August. So August is of how many days? That is of 31 days. So let's count whether or not these values are for all 30 days, 31 days. So let me count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 and 31 days. So there is 31 days in month of August. So these are the information of sunshine in that month. Now the question says that illustrate this data on a stem and leaf diagram. So I have made this ready to explain about how to draw the stem and leaf diagram. So first of all, usually what happens actually in the stem side, we take the values of tens or like this, or also hundreds, also of thousand and something like that. And in leaf part, we usually take unit place values. All right. So in the tens place, suppose that this is 7.0. For a while, I am taking this as 70, 76, something like that. And I kept on searching at the tens place value, that what is the smallest number. So here when I searched it, the smallest number was 0. So I started to write the value from 0. Now in the same way, I searched for the highest value among this in the tens or at the hundreds place. So definitely I can find it is at the tens and hundred place value as it is 12 is the maximum here. So I end up this number writing at 12. Therefore in my stream part the values are 0, 1, 2, 3, 4 and something like this. And the other side, that is the right side of a stream, is called the leaf. So leaf includes the unit place values in the given number, in each number here. And combination of this stream and leaf in the same number, in each case, this sort of diagram when formed is called the stream and leaf diagram. So this is a kind of grouping the data, and also once you group the data, it will have a form of diagram. Okay, now the tens values and hundred values are already collected here. Now I look for another place, that is the ones place. In fact, this is decimal point, so it's tenth in this way we can say here, but we suppose 7 as tens place and 0 as at the ones place, and similarly for other numbers as well. And most important feature of this diagram, to define the key yourself so that observer can understand how you have grouped the data. What is the meaning of number in this diagram? So for example, if I write 3 to the stem and 8 to the left side, and if I define that is means 3.8, then what happens with 0? Let me check that first. With 0 number is 0 here. So it is 0 in the stem and 0 in the left means 0.0. And another number 6, if I am writing here another number 6, that means in the stem part 0 and at the left part 6, that means 0.6. all right. So in this way we understand the reading of the value from stem and left diagram. So let's check with 0 how many numbers we have. With 0 we have 0, then 6, then another number as 8. And then do we have any more numbers? Yes, this is 2. all right. So we have 4 numbers with 0. Now with 1, let's check with 1. Let me find 1. Where is it? So you have to keep on going this way, one by one, start from beginning. So with 1 there is only one number I found, that is 6. So to the stem side 1 and to the left side it is 6. So according to how we have defined the key, 1 6 means this is 1.6. okay. Now with 2 I can see that there are 4 and 6. So with 6 I have got the value 821. So this is 8 and this is 2 and this is 1. And with 7 my value is 0 6 5 5 3 5 5 3 and 8. And now with 8 my values are 3 and 4. And with 9 my values are 8 7. With 10 I have only one value 4. And with 11 I have 1 6 and 3. And with 12 I can see with 12 it is 12.5, so it is 5, and another value is 12.9, so this is 9. Let's count whether or not we have 31 values. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 and 31. So we have covered almost of these values, but what I can see that this is only the first draft. So this is the rough diagram. If you can do the final diagram directly, you can do so, but it will be difficult whenever the number of observations is large. So that's why it is important to go through the first draft first, and then you can arrange this in order. And the when you prepare the final diagram, you have to use the same key, like 3/8 means it is 3.8. That means 12.5 will be read as 12.5. So now we shall arrange this data into order. So in ascending order, so it is first value is 0, then second is 2 6 8. Then with 1 there is only one value, and then it is already in order, so 4 and 6. Now 8 3, so first we write 1 this, with 2 4 6, and with 3 we have nothing here, and but with 4 we have 8 3, so first of all we write 3 and then 8 in the ascending order. And then with 5 we have 6, again 6, then 8, that is almost in order, already in order. And now here first number with 5 is 6 6 8. Now we have another number 6, so with 6 we have 8 2 1, that means we have 8 2 1. So first of all we write 1 2 and 8. And with 7, so smallest number is 0, second smallest is 3, and then 5, again 5, this is 5, again 5, then we have 6, then we have 8. So we have covered all these values, 1 2 3 4 5 6 values, 1 2 3 4 5 6 values in order. And with 8 we have 3 4, so we write here first 3 and then 4, this is already in order. And with 9 we have 8 7, so we have right in order, that means first 7 then 8. With 10 we have only one number 4. Now this is 11, so it is first 1 and then another is 3, then 6, and lastly with 12 it is already in order, that is 5 and 9. So we have covered all these numbers. So this is the first draft and this is the final draft. So this final diagram is the main leaf and esteem and leaf diagram. So by dint of this sort of diagram, you can have a lot of information. A lot of information means you can find the mode of the data. For example, in this case I can see 5.6 and 5.6, that is repeated twice over here, and then 7.5 7.5 have been repeated twice over here again. Now can you see any other numbers? Yes, it looks that like there are more than one mode. And also later in this chapter, whenever you require to find the median, you can divide this data into exactly half, Then the positional value at the middle is the value of will be the value of median. Similarly, from the upper half you will be able to find quartiles, and from the lower half and first quartile, and from the upper half the third quartile, and median itself will be the second quartile. And this will also be easy to calculate the arithmetic mean of this data. And other speciality is that we can compare the two type of data together, like which one has high rate of increase, which one is in more decreasing order, and something like that. So by dint of esteem and leaf diagram, you have a lot of information, you have a lot of opportunity to analyze the data in different ways. Next, we'll see that back-to-back esteem and leaf diagrams, that is also called the back-to-back esteem plot. Okay guys, now we shall discuss about back-to-back esteem plot, and that is also called back-to-back esteem and leaf diagram. So this diagram can be used to compare two sets of data by showing them together on a back-to-back esteem and leaf diagram. So let's see the example. The example states that these are the pulse rates of 30 company directors measured before and after taking exercise. Before exercise, the pulse rates are like this. So this is 110, 93, 81, 75, and like this. And another data of pulse rates after the exercises like 117, 81, 77, 108, 130, so forth. And based on this data, first of all, you have to draw a back-to-back esteem plot. And once you complete your drawing, then you have to compare these two data. That means it says that compare the pulse rates before and after exercise. So in order to draw the leaf and back-to-back esteem plot, first of in the simple kind of esteem and leaf diagram, so esteem are to the left and the leaf part is to the right, and in those case only one key word would work here. Only key will be enough for the simple kind of esteem and leaf diagram. But here we are plotting these two data on the same diagram, therefore we have to define the key in different ways. So you can see here, like at the middle this is 5, and to the right of this 6, so it will be written as 56, and to the left of 5 it is 4, it will be written as 54, not like 45 here. And also it's up to us that how we define the key so that observer can understand about the diagram, that what the diagram is going to speak about. So this is up to us that how we define so that we can make it clear to the audience. So here how we define this key, like 4, 5, 6, 5 in the middle. So 5, 6 means this is 56, and that is used for after exercise part. And then it is 5, 4 from middle to left, it is 54, and it has been used for the before exercise pulse rates. Now we have to develop the number in the esteem first. So in order to develop in the number in the esteem first, so among this data, you have to find in the tens place or in the hundreds place what is the minimum value and what is the maximum value. So if I check through this before exercise, I found the minimum value at the tens place is 4 in the 48. So I started with 4. If there would be 2 in the minimum place, I would have started with 2. If there would be 19, for example, I would have started with 19. And when I start with 4 as minimum number, we have to see the common fact here. So this is 4 in minimum value in the tens place, the before exercise, but 4 doesn't appear here. That means this 4 will not apply to the after exercise. Similarly, I will go to 5, and 5 is definitely here in the first data before exercise, but I can check here. Let me check if any number starts with 5 in the tens place. No. Then 6, yes. If I go to the first data, 6 is common. 6 is for before exercise, like 69 here. For the before data, 69, and there are so many 6 at the 10th place that contains other numbers at the unit place. But for the after exercise, there is only one value, that is 69, where in the 10th place this is 6, and at the unit place value This is 9 only. So just earlier we have seen about the simple kind of esteem and leaf diagram, that if a number is 12, for example, then in esteem part we put for which the place value is 10 in esteem part, and the unit place value to the leaf part. Similarly, for example, if you are given number 112, then we have to take tens place value and hundreds place value to the esteem part, and this unit place value to the leaf part. So those sort of activity we have done. So here we are doing the same work but in twofold on the same diagram. So let's check here. If there are only few values, in that case you can write your plot directly in the final form. But if there are so many data given, then it will be very difficult to write the final diagram. Therefore, what we do actually, for example, if I am working with 4 and with before exercise, I'll check with this number. I will start from beginning and keep on working at my preference of reading, and then with 4 the first number is 8. Now if I move forward, I didn't find any number. The 10th place is 4. So this is all for 4. Now I will start with 5, for example, in before exercise case. So it is 5, 5, 5. I will start from beginning of in the preference of my reading of the number, and 5 I got it. So in front of 5 there is 3. So I wrote here 3. And then let me check if there is another 5 value at the 10th place. Yes, 5, then 0. So I put in the esteem leaf part as 0. Then again in front of 5 there is 7, so I put here 7. And then let me check again. Yes, in front of 5 we have worked up till 5, 7. Then let me check 5, 5, 5. Yes, 1, 51, and then another 51. That makes 1. And I do the similar work for 6, 7, 8, 9, 10, 11, 12 up to 14. For example, if I'm talking of 12 in before the exercise, I don't see any number is 12, so we leave this blank. Similarly, I don't see any number starting with 13 at the tens and hundreds place, therefore we leave it blank here and blank here. Now we shall do the similar work with the after exercise. So it doesn't have the number in the tens place as 4, so we just keep it as it is. So we don't write anything here. Similarly, 5 we don't find in the tens place, so we just leave it vacant. Now let me check with 6 in the after exercise of the pulse rates. So 6, 6, 6, yes, this number is 9. And let me check if there is another 6 also. No, I don't see that another number with 6. That is only 69, so there will be 9. If there will be not even any number, we will not write anything. Similarly, let me check with 7. Then I start beginning here 7. So in front of 7 is 7. Then another 7. Yes, again 7 because 77 because of. And then let me check 70. So it is 0 in the unit place. So we write in the unit place is for the leaf. And then yes, 5 after 7. So we write 5, and here again 75. So we write here 5, and we'll repeat the similar work with other numbers in the esteem, and our diagram is like this. So this is only the rough idea of the back-to-back esteem plot. This is not the final diagram. So in order to draw the final diagram, we have to do only one extra job here, like we arrange this number in the ascending order. So for this part, from left to right, it should be in the ascending order, and to the left, it should be from right to left in the ascending order. So that is only the work that we have to do after we draw the first draft of this esteem and leaf diagram. That's why I have written here that now arranging the data in this esteem plot. So we have arranged this data in ascending order from either side, and then I have repeated the same key over here, and this is my final diagram ready. Next, the question says that compare the pulse rates before and after exercise. Then you can have a look at this data and analyze this. You can see that the minimum value for the pulse rate before the exercise was 48, but minimum value of after exercise starts from 69. And here also the maximum value ends at 45 for the after exercise, but for the before exercise it ends at 111 only. So when you compare both sides, so start of the minimum value and also the end with the maximum value, in both the cases after exercise shows the higher value. And although there are some other features that you can analyze here in order to find that which rate is much faster. So you can do so also, but you don't need to go to that detail at this time. Just by your observation, you can just have a look at this data and analyze it, and then come to the conclusion. So when you analyze this data, you can see that by comparison, means by comparing these two, we can see that pulse rates much faster after the exercise. So this is the answer for part 2. We are left with histogram, so I'm not going to do at this time. We shall discuss about histogram in the next class. So that is all for now, and thank you for your patience.